the white port. USB 1.0 and 1.1. Back in 1996, the tech world was a chaotic mess of proprietary cables and massive 25-pin serial connectors that took up nearly 2 inches of space on your motherboard. The white USB port arrived as a universal savior, aiming to replace that jungle of wires with a single low-cost, slim slot less than 0.5 inches wide. This white-coated plastic inside the port isn't just a design choice, it's a timestamp of an era where moving 12 megabits of data per second was considered groundbreaking speed. It changed everything by allowing you to hot swap devices without rebooting your entire PC, a feature we completely take for granted in the 2020 S. The biggest hurdle with this antique is its half-duplex nature, which functions exactly like a digital one-way street. Data can travel to your computer or away from it, but the hardware is incapable of doing both at the same exact time, creating a massive bottleneck. If you tried to transfer a standard 700 megabyte CD's worth of data today, you'd be staring at a loading bar for nearly 8 minutes straight. It provides a meager 2.5 watts of power, which was just enough to juice up a basic 101-key keyboard or a simple 2-button mouse. While it's almost extinct in 2026, every high-speed connection we use today owes its DNA to this simple, white plastic ancestor that first taught our computers how to talk to everything else. The black port, USB 2.0. Enter the year 2000. The black USB port? This is the undisputed OG of connectivity that powered the rise of the modern PC era. It boosted data rates to 480 megabits per second, a massive 40x leap over its predecessor, yet it still clung to that old-school one-way street data lane. While it's the backbone for your mouse and keyboard, its power delivery is measly, capping out at just 2.5 watts or 500 milliamps at 5 volts. And if you tried to juice up a modern smartphone using this port, the device wouldn't even break a sweat, staying cool at a room temperature of 72 degrees Fahrenheit. Because the energy flow is too weak, it can't even trigger a fast charge cycle. This happens because of its half-duplex architecture, meaning if a drive tries to read and write at the same time, the speed collapses instantly, transferring a 4 gigabyte high-definition video through this black plastic slot will keep you waiting for over a minute. And backing up a 50 gigabyte photo library would burn at least 15 minutes of your life. Despite these limitations, black ports remain the most compatible piece of hardware in history. They are incredibly cheap to manufacture and exceptionally stable, which is why almost every modern motherboard still reserves a few slots for your basic peripherals. They don't generate much heat, typically staying within 5 degrees Fahrenheit of the ambient air, making them the most reliable choice for low-bandwidth tasks that don't require 10-lane highway speeds. The blue port, USB 3.0. Fast forward to 2008, the tech industry decided that waiting for files was officially over and introduced the blue port, famously branded as Super Speed USB. This wasn't just a minor speed bump, it was a total reconstruction of how computers talk to hardware. With a theoretical bandwidth of 5 gigabits per second, it's like upgrading from a rural dirt road to a massive 10-lane highway. You can now transfer that same 4 gigabyte movie in under 15 seconds. A feat that felt like science fiction on the old black ports. It also bumped the power output to 4.5 watts, finally allowing external hard drives to run without needing an extra clunky wall adapter. The real magic is hidden deep inside the connector where you'll find 5 additional copper pins, bringing the total to 9. This secret hardware upgrade enabled full-duplex communication, allowing the port to send and receive data simultaneously for the first time in USB history. This means while you're backing up a 50 gigabyte project to an external SSD, you can still pull data from it without the connection stuttering. It is the perfect choice for high-resolution webcams and video capture cards that demand a constant, high-speed flow of information. The blue port didn't just make things faster, it made the modern, high-bandwidth digital lifestyle possible. Its physical design is so robust it can handle thousands of plug-in cycles without losing its signature 5 Gbps grip, ensuring your data moves at peak efficiency for years. The teal port, USB 3.1 Gen 2. Just when the world got comfortable with blue, the teal or light blue connector arrived to completely rewrite the rules of high-speed data. While it looks deceptively similar to its predecessor, this port is a specialized beast engineered for the most demanding professional workflows. It officially represents the USB 3.1 Gen 2 standard, which effectively doubles the stakes by pushing a massive 10 gigabits per second of bandwidth through its tiny copper lanes. In the real world, this translates to blistering transfer speeds ranging between 700 and 900 megabytes per second. making it nearly impossible for the port itself to become a bottleneck. The most impressive feat of the teal port is its ability to handle uncompressed 4K video streams in real time, allowing professional editors to work directly off external NVMe SSDs without a single frame of lag. If you were to move a massive 100 gigabyte project file, this speed assassin would finish the job in just over 2 minutes, whereas older standards would leave you waiting for an entire lunch break. You'll typically find these ports on high-end motherboards or specialized workstations designed for heavy-duty content creation. It is the silent workhorse for the digital age, ensuring that as our file sizes grow into the terabyte range, our connection speeds are always one step ahead. It's not just an incremental update, it's the hardware foundation that allows modern creators to push the boundaries of high-resolution digital media. The red port, USB 3.2. Red has always been the universal color for power and intensity. And in the high-stakes world of computing hardware, the red USB port lives up to that reputation perfectly. These ports act as the premium special forces of your motherboard, often representing the cutting-edge USB 3.2 Gen 2 or even the Gen 2 X2 standard. This engineering marvel allows for screaming data speeds between 10 and 20 gigabits per second, letting you move massive libraries of information in the blink of an eye. Whether you are a hardcore gamer loading 100 gigabyte titles or a data scientist handling massive datasets, the red port ensures your hardware is never left waiting for the bus to arrive. Beyond raw speed, the true brilliance of this connector lies in how it manages electricity through a sophisticated feature called sleep and charge. This specialized circuitry allows the red port to remain fully energized even when your computer is completely shut down, effectively transforming your multi-thousand-dollar PC into a massive, high-efficiency power bank. You can plug in your smartphone or wireless headset at midnight, and the port will continue to pump out a steady stream of juice, often reaching internal temperatures around 105 degrees Fahrenheit as it works tirelessly to fast charge your devices while you sleep. It is a masterpiece of modern utility that balances extreme performance with daily convenience, ensuring your gear is always topped off and ready for action by 8:00 a.m. without ever needing to hunt for a wall outlet. The yellow port. Yellow USB ports are a rare sight on flashy gaming rigs, but they are a hallmark of elite business-grade hardware, like the legendary Lenovo ThinkPad series. While most connectors prioritize raw data transfer, the yellow port is a specialized utility hub designed for the modern professional. It typically operates on the USB 3.0 architecture, providing a respectable 5 gigabits per second of bandwidth. But its true mission is constant power delivery. These are high current, always-on stations engineered with premium voltage regulators that can withstand the electrical stress of 247 operation. The defining characteristic of this hardware is its ability to bypass the system's power state entirely, allowing it to charge thirsty 10-inch tablets even when the laptop is in deep hibernation or completely powered down. This isn't just a basic electrical bypass. It is a sophisticated power management solution that ensures your critical gear reaches a full charge by 8:00 a.m. It provides a rock-solid energy flow of 5 volts and up to 1.5 amps, which is a significant step up from the standard 0.5 amps found in legacy black ports. This stable current remains consistent even in fluctuating environments, making it indispensable for field engineers who rely on their 3 LLB Ultrabooks as their primary power source. In a world where battery anxiety is real, the yellow port acts as a reliable, stationary power bank that is always ready to serve. It represents the pinnacle of utilitarian design, proving that sometimes the most valuable feature of a port isn't how fast it talks, but how long it can provide life-sustaining energy to your mobile ecosystem. The orange port? In the highly regulated world of technology standards, the orange USB port exists as a fascinating wildcard that defies official USB-IF color coding. Because there is no universal mandate for this hue, manufacturers have reclaimed it to signify specialized, high-performance functions. On some high-end gaming motherboards, orange is the designated signal for VR-ready connectivity, featuring isolated electrical lanes to prevent the microscopic signal interference that causes motion sickness in virtual reality headsets. It is a brilliant example of how hardware can be tuned to solve specific human sensory problems through cleaner data transmission. However, in the world of heavy-duty computing, the orange port takes on a much more rugged personality. Many industrial-grade machines feature orange ports that have been physically reinforced with high-tensile steel brackets, designed to withstand over 20 pounds of accidental pull force without damaging the internal copper pins. This makes them the go-to choice for factory floor environments, where cables are frequently yanked or snagged by moving machinery. In other scenarios, orange is used to mark dedicated diagnostic ports capable of sustaining 10 gigabits per second while providing specialized system access. Technicians use these ports to flash a corrupted BIOS or run low-level system recoveries that standard ports simply can't handle. It is the ultimate utility player of the hardware world. A color that tells you the manufacturer has added something extra under the hood. Whether it's providing 10 Gbps of speed or serving as a reinforced lifeline for industrial equipment, the orange port proves that when standard solutions fail, custom engineering takes over to ensure maximum uptime. The green port. The green USB port is perhaps the most deceptive entry in this list because its meaning shifts entirely, depending on whether you are looking at a laptop or a wall adapter. In the PC gaming world, green is famously associated with Razer, a brand that prioritizes its acid green aesthetic above all else. Razer customizes every single USB port on their laptops to be green, just to match their iconic logo, completely ignoring the industry standard where green usually implies a specific charging speed. This means a green port on a Razer blade could technically be a standard 5 Gbps or 10 Gbps connection, serving more as a fashion statement than a technical spec. However, once you step away from computers and look at mobile wall chargers, the green core takes on a very real, high-tech purpose. It serves as the universal signal for Qualcomm quick charge technology, specifically versions 2.0 and 3.0. These ports are engineered to communicate intelligently with your smartphone, dynamically jumping from the standard 5 volts up to 9 or even 12 volts. This allows the charger to slam power into a drained battery at record speeds, often taking a phone from 0% to 50% in under 30 minutes. It is a brilliant example of how hardware uses color to signal a handshake between the charger and your device, ensuring that while the energy flow is intense, the internal circuitry never exceeds a safe temperature. The purple port. You won't find a purple USB port on a standard PC motherboard, as this color is a specialist, reserved exclusively for the high-stakes world of mobile fast charging. Brands like Huawei and Oppo use these purple plastic cores to identify their proprietary SuperCharge and VOOC systems, which operate on an entirely different philosophy than standard USB. While most chargers increase voltage to gain speed, these purple ports focus on massive amperage, often pushing a staggering 5 amps or even 6 amps of current through the cable. To handle this intense electrical pressure without melting, the internal copper pins are custom widened and paired with specialized cables featuring thicker, low-resistance internal wiring. This specialized hardware allows a smartphone to reach nearly 100% capacity in about 40 minutes, a feat that would take hours on a traditional black port. Because the power delivery is so intense, the port and cable must perform a constant digital handshake to monitor thermal levels. If you use a generic cable with a purple port, the system will instantly throttle back to prevent the connector from exceeding a safe temperature of roughly 110 degrees Fahrenheit. It is a masterpiece of modern mobile engineering, proving that sometimes the most effective way to solve the battery crisis isn't through software tricks, but through raw, high-amperage hardware brute force. USB-C and technical icons. The USB Type-C connector represents the definitive shift in hardware design, effectively ending the era of color coding in favor of a unified, reversible interface. This slim port is less than 4 inches wide, yet its physical uniformity hides a massive range of internal capabilities that color can no longer describe. A plain black or gray USB-C slot could be a legacy 480 megabits per second connection, or it could be a top-tier Thunderbolt 4 port screaming at 40 gigabits per second, because the visual cues of the past have vanished. Mastering the symbol language printed next to the port is now the only way to avoid a performance bottleneck. If you see the letters SS, you are using a 5 Gbps superspeed port, while SS10 or SS20 signals a massive jump to 10 or 20 Gbps of bandwidth. A tiny battery or lightning bolt icon indicates the port supports power delivery, capable of pumping up to 100 watts or even 240 watts to charge a high-end laptop. The most powerful symbol is a lightning bolt inside a circle, representing the Thunderbolt standard, which can drive two 4K monitors at a 60 Hz refresh rate while moving data at maximum velocity. This transition from visual colors to technical icons represents the ultimate evolution of computing connectivity, where a single, universal design can handle every digital task in the modern ecosystem.